Hello guys, the topic of this video is limit for piecewise functions. We will be studying two types of piecewise functions. The first type having equal not equal condition, the second type having less than and greater than condition, or less than or equal to, greater than or equal to one of them has equality in it. Alright, for the first type, to find f of c, if we're asked to find the value of the function at the given point, then we will be using the equal condition. But if we are asked to find the value of the limit at the given point, then we will be using not equal condition. Okay, for example, let's take a look at that ministry question. If we are asked to evaluate f of, let's say, f of minus 2, if this were the question, then the answer would be 0. We look at the equal condition if we are asked to find the value of the function at the given point. But when we are asked to find the value of the limit x as x approaches to negative 2 of f of x, then we will check not equal condition, which gives us 1 right away. So both of them are in options. 0 is in B, 1 is in A. So which one is true? This is equal condition for finding the value of the function, but this is not equal condition to find the value of limit. What we are asked is limit. So for limit, we check not equal condition. So answer is A. So we are not solving, we are just knowing the answer by knowing the information. Alright, another question. What if we don't have just numbers here, we have functions? What happens? For example, here in exercise question, we are still asked to find limits. So for limits, we check not equal condition. So which is the first condition? So we will write limit as x approaches to 2 of f of x. Our f of x becomes 4 minus x. So evaluating the limit, you just substitute the number that x is approaching for x. So it is 4 minus 2, which is 2, right? If the graph is given, then it is easier actually. You don't have to solve it. You can just check it on the graph. For the graph, when you approach 2 from right, the graph is approaching to that point. When you approach 2 from the left, the graph is approaching to the same point, which is 2. Right? But the questions won't give you both of them at the same time. They will either give you the function, or the graph. Right? That was the first type. The second type, having less than and greater than, or one of them has equality in it. So in order to find the value of the function, we should check the equal condition. So if there is only less than and greater than in the conditions, then there is no equality. So function is not defined. Function is undefined. But if one of them has equality in it, like this, we check the equal condition for finding the value of the function. Or less than, greater than, or equal to. So we check this equality, the one that has equality in it, to find the value of the function at that point. Alright, otherwise the function is undefined at that point. Alright, what about for finding the limit? For finding the limit, as you can know, in order to find limit from right must be equal to limit from left. Left side limit is equal to the right side limit, then limit exists, and the value of the limit is the value of the right and left side limits value. So to find left side limit, we will check less than condition. To find right side limit, we will check right side condition. So left represents left side condition, right represents right side condition. If finding left side and right side condition gives you the same value, then limit exists, and that is the value of the limit. For example, Let's take a look at that. Check it out question. It's asking about the limit. So there is less than greater than condition. So we will be using the second type, the way of the second type limit condition. So to find limit, limit as x approaches to 0 from left must be equal to limit as x approaches to 0 from right. That will be the value of the limit at 0. Okay, let's find them one by one. For the left side limit, we will be using less than condition. For the right side limit, we will be using greater than condition. So for left side limit, less than condition, first condition, first case. So limit as x approaches to 0 from the left of x minus 1. So when you insert 0 for x, it's going to be negative 1. What about the right side limit? Limit as x approaches to 0 from the right of the function in the third condition is negative x negative 1. When you insert 0 for x, it's still negative 1. So right side limit is equal to the left side limit. Then the value of the limit is equal to negative 1. So that's the answer. All right. Next question. It's asking about, check it out question asking about the limit. So we check both right and left side condition. For the less than condition, left side. For more than condition, right side limit. So limit as x approaches to 0 from left of the function, the corresponding function is x minus 1. Inserting 0 gives you negative 1. Right side limit. Limit as x approaches to 0 from right of x plus 1. Inserting 0 for x will give you 1. So right side limit is not equal to the left side limit. One of them is negative 1, the other one is 1. So then limit as x approaches to 0 of f of x does not exist. So we can talk about limit at that point. All right. Okay, another question, ministry question and test prep question. Which one is false? Check each option one by one. F of 1 is not defined. How do you find the value of the function at given point? By using equality. Where is the equality? Equality is in the middle condition. It is 1. It is defined. So this is false. 0 from right exists. Limit 0 from right. Where do we look for right side limit? 0 from right is here, the first case. So limit as x approaches to 0 from right of the corresponding function is 2x. Inserting 0 for x will give you 0. It is a real number, so it exists. True. And C, 2 from left does not exist. Let's check. Where is 2 from left? Here. 2 from left is the last case. The limit as x approaches to 2 from left of the function is negative x plus 3. Inserting 2 will give you 1. It exists. It does exist. So it is false. The limits as x approaches to 1 of f of x does not exist. So since it's piecewise function, less than and greater than case, we don't have equal not equal case, then we check right and left side limit. So if limit as x approaches to 1 from left is same as limit as x approaches to 1 from right of f of x, then we have a limit. So let's check left side limit. For the left, we check the first case, 2x, insert 1 for x, it is 2. For right side limit, we check the last case, negative x. Negative x plus 3. Substitute 1 for x. Negative 1 plus 3 is 2. So right side limit is equal to the left side limit. Then limit as x approaches to 1 of f of x is equal to 2. It exists. So it is false then. It says it does not exist, but it exists. Actually, it is false. Last one. Limit as x approaches to 1 of f of x is not equal to f of 1. What was the limit? We just found it in the previous part. We found this as 2, right? So this is 2. What is the value of the function at 1? At 1, the value of the function is 1. So as you can see, 2 is not equal to 1. It is true. What are we looking for? We are looking for false statements. Which statements are false? D is false. It says limit at 1 does not exist, but it does. And C is false. From left side of 2, limit exists. It has a real number. And what else is false? The first statement is also false because f of 1 is 1, not defined, it's defined. So there are 3 false statements. All right. So those are the related questions. Now let's continue with the last part of this topic. Piecewise, writing absolute value functions as piecewise. All right, we studied this in grade 10. Let me remind you. If you have an absolute value function, you can write this as piecewise as 2 different conditions. So if the inside function, if the number inside is negative, then you'll take the opposite of the function out. If inside is positive, you take the same function out. Opposite will come out if inside is negative. Same will come out if inside is positive. For example, let's suppose you have negative 1. The inside absolute value is negative. How does it come out? It comes out as 1. Is 1 same or opposite? It is the opposite. So it's like x. Instead of having negative 1, you have an x. X is negative, so x becomes negative x. The sign changes. See, negative 1 doesn't come out as negative 1, it comes out as 1. So sign changes. That's why it becomes negative x. Just because we have negative x doesn't mean that the number is negative. It makes the number positive. To make the number positive, we multiply it by negative. It's like negative 1 multiplied by 1 by negative to make it positive. You're supposed to get positive 1 out. The number is negative 1. You multiply it by negative. That's why you have this negative in front of this x. And if the number inside is positive, like 1, it's gonna come out as 1. So same will come out. Nothing changes, like x coming out as x. Right? This is the idea. So this is how you write an absolute value as piecewise function. So we will use that idea. All right. Evaluate limit as x approaches to 0 of f of absolute value x over x. So first of all, we do plug-in, see what kind of condition we have. If we do plug-in 0 for x, then we have 0 over 0 case. Okay, we studied a few techniques to solve 0 over 0 conditions, like factoring the common out. We don't have such option here. Rationalizing, we don't have an option here. And combining fractions, we don't have such case here. And trigonometric functions, we don't have such condition here. So this is not one of the conditions, one of the techniques that the techniques that we studied will not work here. It's something else. So we should get rid of this absolute value first. How do you get rid of the absolute value? So you know that in order to have a limit at a point, then right side limit must be equal to the left side limit. So what is right side limit? What is left side limit? We should figure them out first. So how do you find left side limit? So when you give a number very close to zero and less than zero, like negative or point something, then the inside is negative. If the inside of absolute value negative, as here, we will take x out as its opposite. So x will come out as negative x. So don't touch denominator. So just simplify the absolute value. So absolute value x will come out as negative x since inside is negative by using this rule. Negative x over x is negative 1. Alright, what about right side limit? 0 from the right. When you pick a number very close to 0 and bigger than 0, like 0.1, then inside the absolute value is 0. Inside absolute value is positive. If inside is positive, then it will come out as positive x. So absolute value x becomes positive x when inside is positive. X over x is 1. So left side limit is negative 1, right side limit is 1. Then we will say limit as x approaches to 0 of that function does not exist. Okay, right and left side limits are different from each other, so limit does not exist. All right, some questions will ask you one-sided limit, not as x approaches to 0, maybe 0 from left, maybe 0 from right, so you should solve it like that. All right, and another way, if you know its graph is like that. For the right side it's 1, it's a constant function, it's 1. For the left side it's negative 1, so it's a piecewise function like that, and both points are excluded. If you know the graph, you can solve it easier. If you don't, you can just solve it by steps, step by step. Next exercise question. Knowing the graph will help you to find the answer, but without knowing, you can still solve it. It is not one-sided limit. It is asking about limit at 5. So when you insert 5 for x, it makes the result 0 over 0, which means we should get rid of this absolute value. Check right and left side limit one by one. Okay, left side limit. If you pick a number less than 5, like 4.9, 4.9 minus 5, inside will become negative. If inside is negative, then the opposite of the function will come out, negative x minus 5. The denominator will stay same, so x minus 5 will cancel each other. The answer is negative 1. What about right side limit? Limit as x approaches to 5 from right of x minus 5, x minus 5. So now you pick a number greater than 5, very close to 5, like 5.1. 5.1 minus 5, inside is positive. So if inside is positive, the same function will come out. Then when they simplify each other, it's 1. Left side limit is negative 1, right side is 1, then limit does not exist. Does not exist. If it were asking about one-sided limit, you would say either negative 1 or 1. So for such cases, it's always 1 and negative 1. Since they are different, then the limit won't exist. Let's take a look at some ministry questions. 2022 first attempt ministry question, option A, which one is true? Question is, which one is true? 3 from the left, you pick a number like 2.9. You just use this in absolute value, not for the other part. It's for absolute value to identify what kind of function will come out. So 2.9 minus minus 3, negative 0.1, which is a negative number. So if inside of absolute value is negative, then its opposite will come out. Negative 3. Opposite of x minus 1, negative x minus 3. In denominator, you have negative x minus 3. X minus 3 will cancel each other. Negative 3 times negative 1, positive 3. It says 1, so it is false. Option A is false. Option B. Let's do plug-in first. Substitute 2 for x. So it's going to be 2 cubed plus 8 over 2 minus 2. 2 cubed is 8, 8, 8, 16. 2 minus 2, 0. So it's not 0 over 0 case, no simplification here. It is directly undefined. Limit does not exist. Okay, whenever you have number other than 0 over 0 condition, then limit does not exist. It's going infinitely. Option B is false. What about option C? Let's try C. 2 from negative 2 from the left. Pick a number less than negative 2, like negative 2.1. When you put negative 2.1 for x, negative 2.1, we are using this number to identify the sign only, not the number. We know that it is negative, it's infinity. When you insert negative 2, it's going to be 1 divided by 0. It's undefined. So we will have an infinity limit case. Then to find the value of this limit, to find the sign of this infinity, we are using the number. So you use this number just to find the sign of the infinity. So negative 2.1 plus 3, it's a positive result. Negative 2.1 plus 2, it's a negative result. Positive over negative is negative. So the sign of infinity is negative. That checks, that's true. So C is true. D. Okay, substitute 0 for x. Do plug in. E to the 0 is 1. Any number raised to power 0 is 1. Cosine 0. Cosine 0 is also 1. 1 divided by 1, 1, not 0. So it's false. So the correct answer is C. Alright. So there are different topics combined here. Here we see on the last topic, that's today's topic. Here we see just evaluating functions, here evaluating limits, here also evaluating limits, here limit at infinity. So we see 3 different topics here in one question. Okay, let's take a look at the last question. Ministry question and partial test question at the same time. I see an absolute value, so I should get rid of this absolute value. So what kind of condition do I have here? When you insert 1 for x, what happens? 1 squared minus 2, negative 1, plus 1, 0, 1 minus 1, 0, 0 over 0. But it's none of the techniques, none of the cases that we studied before. So none of the techniques will work here. We just need to get rid of the open this absolute value by checking right and left side limits. So limit as x approaches to 1 from left first. X squared minus 2x plus 1 over x minus 1. So when you pick a number less than 1, like 0.9, then 0.9 minus 1, it's negative. Inside being negative means the function's opposite will come out. What do I have at the top? I think it's factorable. So let's factor this out. Let's do the factorization. X, this is negative 1 because the middle term sign is negative. Negative 1 times negative 1, 1. Negative 1 plus negative 1, negative 2 gives us the middle term. So that's correct factorization. So at the top, I have x minus 1 times x minus 1. Right? Now, x minus 1s will cancel each other. I'll have x minus 1 divided by negative 1. insert 1 here. It's going to be 1 minus 1 over negative 1, 0 over negative 1. So it is 0. The answer of the left side limit is 0. Let's do the same for right side limit. X squared minus 2x plus 1 over absolute value x minus 1. So when you pick a number greater than 1, like 1.1, then 1.1 minus 1 is 0.1, which is positive. Since inside is positive, it's going to come out as positive x minus 1. And the factorization of this is x minus 1, as I did above. X minus 1. X minus 1s will cancel each other. You will left with x minus 1. So when you insert 1 for x, 1 minus 1, 0. So right side limit is same as left side limit. Then limit as x approaches to 1 of the given function is also 0. So it is C. Alright, so whenever you see absolute value, you open the absolute value by checking right and left side limit. To check left side limit, you pick a number less than the number that you are approaching. For right side limit, pick a number greater than the number that you're approaching. So if you have negative inside, take the opposite of the function out. If you have positive inside the absolute value, you take out the same function out. By doing this, you would be getting rid of the absolute value, opening the absolute value. And then after simplifying and stuff, you will find your answer. So in this case, we have a limit exists, but in the previous questions, like absolute value something over the same thing type, limit does not exist. Alright, so let's summarize the conditions that limit does not exist. So limit does not exist if right side limit is not equal to the left side limit, like these questions, like those questions, or like the other type. Then you check right and left, you won't get the same answer. That limit does not exist. And the other type of questions that limit does not exist, we have infinite limit, unbounded limit condition. So from right or from left, it goes to positive infinity, or one side goes to positive infinity, the other side goes negative infinity, or both goes positive or both goes negative infinity. So it goes unbounded, then limit does not exist. And the other condition that limit does not exist is the oscillating behavior condition. So this is an exercise question. It was asking about describing 3 types of conditions that limit does not exist. Then these are the conditions: oscillating behavior, infinite limit condition, and right side limit being not equal to left side limit. Okay, that's it for this topic.